If I ask you all, which are the distinct seasons that are experienced in India, most of you will be able to answer it correctly. According to our Hindu traditional calendar, there are 6 distinct seasons, starting with Vasant, Grishya, Varsha, Sharad, Hemant, and Shishir. The IMD compressed these 6 seasons into 4 major ones, naming them as summer or pre-monsoon, monsoon or southwest monsoon, retreating monsoon, and winter or northeast monsoon. From the classification produced by IMD, it is quite evident monsoon is a phenomena which plays an important role in determining the seasons and ultimately the climate of the country. Now the question arises, what is monsoon? If we just start with the name itself, monsoon is derived from an Arabic word mawsim, which translates to season or wind shift. The Arab sailors studied this predictable wind pattern for having safe voyage to and from the Indian subcontinent. So for being such an important factor, the climate of India is tagged as tropical monsoon climate. Now why monsoon is predominant in the tropical regions, you'll get to know that by the end of this video. So if we focus on the term mawsim, it says it's a seasonal wind or wind shift that purely states the monsoon winds changes the direction according to the seasons. But how? To answer this, we need to study 3 theories. Theory by Sir Edmund Halley, by Hermann Flohn, and by P.Koteswaram. Sir Edmund Halley of Britain was an English astronomer who proposed the thermal concept of monsoon in 1686. Now to understand this theory, first we need to have a brief knowledge of wind movement from high pressure to low pressure, which we shall analyze through the phenomena of land breeze and sea breeze. During daytime, the landmass, being solid, gets rapidly heated and develops low pressure. At the same time, sea, being fluid, remains comparatively cooler than land and hence develop high pressure. The wind during daytime hence travel from sea, that is high pressure, towards land, that is low pressure, and this is tagged as sea breeze. This movement of wind from high pressure to low pressure is driven by pressure gradient force, which pushes air from densely packed molecular region to places where air molecules are less spread out. At night, the exact opposite takes place. The land rapidly loses heat and becomes comparatively cooler than the sea, and hence develops a high pressure, whereas the sea, being comparatively warm, develops a low pressure. And now the wind travels from land towards the sea, and we tag it as land breeze. Sir Edmund Halley propounded monsoon winds were large-scale land and sea breeze, which also gets generated from differential heating of land and water. During the summer, due to inclined axis of the earth, the northern hemisphere remains tilted towards the sun. During this period, an intense low pressure gets formed over northwest India. At the same time, a high pressure zone is created in the southern Indian Ocean, as the southern hemisphere is tilted away from the sun. Due to the difference in pressure condition, the wind travels from high pressure, that is from the sea, towards the land, experiencing low pressure, just the way we got to see in sea breeze. Now, what have we learned? Monsoon winds reverse its direction in different seasons. So during the winter season, when the northern hemisphere is tilted away from the sun, the subcontinent develops high pressure. And now the southern Indian Ocean has developed low pressure. Hence, the wind now travels from land towards the sea, as the position of low pressure and high pressure been reversed. Next, we shall learn about the dynamic or ITCZ theory of 1951 propounded by Sir Hermann Flohn of Germany. He criticized the theory of Sir Edmund Halley and argued differential heating of land and water is not enough for reversing the movement of wind at a global scale, and presented shifting of the pressure belts to be the main factor for occurrence of monsoonal winds. Now, what are pressure belts? These are distinct zones in both northern and southern hemisphere having alternate pressure conditions according to the amount of insolation they receive. Now, if you all want to learn about the pressure belts in more details, I have attached a link in the description section of this video. So in this case, the same principle gets followed in terms of wind movement. It will travel from high pressure belt towards the low pressure belt. But the twist is, the pressure belt shifts their position. During summer, when the sun comes directly above the Tropic of Cancer, then all the pressure belts shifts 5 to 10 degrees northwards following the path of the sun. Again, during winter, when the sun shines vertically above the Tropic of Capricorn, then all the pressure belts shifts 5 to 10 degrees towards the south. Now, as the position of the pressure belts shifts, the wind movement across the pressure belts change their track. Now, in the beginning of the video, I called this as ITCZ theory. Now, what is ITCZ? It is an acronym for Intertropical Convergence Zone. ITCZ is a global belt of low pressure found near the equator, where trade winds from northern and southern hemisphere meet. And as they converge, the heat leads air to rise, cool and condense, creating bands of persistent clouds having rain and thunderstorm. The zone of ITCZ that normally lies around the equator shifts 20 to 25 degree north latitude, roughly parallel to the Himalayas. The southeast trade winds coming from the southern hemisphere, which was supposed to converge with northeast trade winds around the equator, now has to travel till 20 to 25 degree north. These winds, as it travels over the sea, absorb moisture and enters Indian landmass as southwest monsoon winds and produces rainfall. A similar situation occurs during the winter, when the ITCZ shifts 20 to 25 degrees south latitude. The northeast trade wind, which was supposed to converge the southeast trade winds along the equator, now has to travel across the entire Indian landmass and then meet the southeast trade winds in the southern Indian Ocean. But as the wind travels from land towards the sea, it carries very less amount of moisture. The final one. The jet stream theory of P.Koteswaram is one of the most accepted modern explanation for the origin of onset and withdrawal of Indian monsoon. It mainly focuses on subtropical jet stream in controlling the incoming and outgoing of monsoon winds over Indian landmass. So first, we need to understand what is jet stream. It's a narrow belt of very fast moving winds found in the upper atmosphere or upper troposphere, usually at a height of 12 to 14 km above the ground. The subtropical jet stream blows from west to east between 20 to 35 degrees north and south of the equator. To analyze the role of jet stream in winter. Position of subtropical jet stream. In winter, it blows south of the Himalayas, creating high pressure and dry condition over northern India. What are the effects? Descending air from the jet stream prevents upward movement of the warm air. As a result, weather remains dry, high pressure prevails. During this period, the subtropical jet stream also carries western disturbance from Mediterranean region, causing winter rainfall in states like Punjab and Haryana and snowfall in Kashmir Himalayas. And there is shift of jet stream in summer. With increasing summer temperature, the Tibetan plateau heats intensely. The subtropical jet stream begins to shift northward. By the end of May, the subtropical jet stream shifts to north of the Himalayas. High pressure formed during the winter gets weakened and low pressure develops over northwest India. This creates an ideal condition for the entry of moisture-laden southwest monsoon winds. The sudden shift of the subtropical jet stream is considered to be the first signal of monsoon onset. The monsoon winds withdraws again when subtropical jet stream shifts south of the Himalayas, which builds high pressure condition in northern India that weakens the monsoon winds. And with that, we come to the end of our discussion on the monsoon mechanism of India. We explored the three major theories proposed by Halley, Flohn and P.Koteswaram. Each theory contributed important insights, and together they help us understand the complexity of the Indian monsoon. If you enjoyed this video, do like, share and subscribe for more content. As the monsoon clouds arrive, bringing relief, greenery and new life across the country, I wish you and your family a happy, peaceful and refreshing monsoon season. Thank you for watching, and I'll see you in the next video.